Good morning, good afternoon, and good evening to all our attendees joining us today for this latest IoT Central webinar. This is David Oro, your host. I am the Editorial Director with IoT Central. I'd like to start by thanking Skyhook for sponsoring today's event. Skyhook is a wonderful supporter of the IoT Central community, and we are honored to have them as partners. This webinar is entitled Implementing a Successful IoT Location Strategy. Before we begin, I'd like to briefly review the format of today's webinar. The event will be 1 hour long. We will have two panelists that I'll introduce in just a minute. There will be a 10 to 15 minute Q&A following the presentation, and this event is being recorded and will be available on IoT Central later this afternoon following the live event. I'd also like to encourage our attendees to provide questions throughout the presentation. We will be reviewing and presenting them on your behalf during the Q&A portion of the event. I am very pleased to introduce today's speakers, Kip Jones and Nick Mellinger. As Chief Technology Evangelist, Kip works to guide and shape Skyhook's innovative technology. He has spent 20 years developing technology and strategy for numerous technology startups, including Newbridges, Pathfire, and his own company, Direct Site Networks. He's authored 19 patents for methods pertaining to Skyhook's hybrid location technology. Kip received his bachelor's in computer science from the University of Nebraska, as well as an MS and ABD in computer science from Georgia Tech. Nick has over 10 years of experience in mobile, emerging, and digital marketing technologies. Skyhook, Nick is responsible for helping to drive the next generation of disruptive location technology, including product development for Skyhook's core precision location hybrid positioning system, as well as their contextual mobile SDKs. Prior to joining Skyhook, he led the mobile and emerging technologies team at Epsilon, managing partnerships and integrating third-party mobile or emerging technologies in Epsilon's core marketing, CRM, and messaging platforms. Nick earned his bachelor's in business management and information systems from Babson College. Thank you for being with us today. We look forward to your presentation. The ability to track or monitor the whereabouts of millions of connected things can be a critical element in a successful IoT solution. But locating IoT devices presents unique challenges due to their intrinsic power, storage capacity, battery life, and processing limitations. Today's IoT webinar, Skyhook, Innovators, and 20-year veterans of mobile device location will present an overview of the IoT-related strengths, drawbacks, and lessons learned for various location methods on the market today, including AGPS, Wi-Fi, cell, and others. Each technology will be examined as it relates to the prevalent IoT use cases and carriage technologies, including LoRa, NB-IoT, Sigfox, among others. Today, attendees will come away with a clear understanding of the key location dimensions for IoT devices, along with a list of 10 questions to consider when choosing a location vendor or technology. Kip and Nick, with that, I'm going to turn it over to you. You can begin as soon as you're ready.
All right. Well, thank you for that introduction. This is Kip Jones, and I want to thank everybody who is joining us today. And hopefully you will come away with everything that was mentioned above. So before we get to the meat of the topic, I want to kind of introduce Skyhook and give some background on why we are on this call and hopefully how we can relate some information we've learned over the years. So we were founded in 2003, and I've been with them since that, so I've been along for the entire journey. Really pioneered Wi-Fi positioning as a global positioning technology, and we've continued to evolve that as the technologies evolved and as the capabilities evolved, and deployments of Wi-Fi have continued to exceed our expectations. The early years were sort of dominated by a method of acquiring the locations of Wi-Fi access points via a method commonly called war driving. That was rapidly eclipsed by a method of really crowdsourcing, using our location service as both a positioning service and a way to continuously evolve the locations of those beacons, whether it's Wi-Fi, cell, and other beacons as they come online. So the capabilities that we've developed has grown over the years, and today we operate a network of location that is providing more than 2 billion transactions across our APIs a day, consisting of over 3 billion Wi-Fi access points geolocated around the globe that we use to constantly position devices out in the field. We are a service that also incorporates GPS, GNSS services into the solution. So we're not a exclusive Wi-Fi or exclusive cell positioning. We think of location as something that every device ought to be able to get, and we try to find ways to get that regardless of what radios are available on a device. So we have hundreds of customers, and like I said, there's a vast amount of traffic going across, servicing all these devices in the field. Some of our IoT partnerships include folks like Sony, Philips Lifeline, to help protect folks who may have fallen down or wandered away. There's Electric Imp. We also work with IBM as a partner with their Watson IoT. And also folks like Sensitech and supply chain. So it spans everything from smartphones. In fact, we were on the original iPhone before it had GPS and continued to work with Apple for a number of years. So with that, I think I'll step into the meat of it, which is IoT and why we would like to help people get through this, what is sometimes an interesting maze for companies. So as a preamble on it, of course, there's so many things. Internet of Things and connected devices span from everything, right? They are going from pet trackers to home security to the industrial IoT scenarios, home automation. You've got everything from planes to trains and automobiles that are connected now through different sensors. Now, one thing on the location side is, we're a location company, so we think everything should have location. But obviously, there are instances and use cases where location is not the main thing or may not be a thing that's necessary for the solution. So if you think about a home security solution for consumers, location may not be really important for that end consumer. The fact that it's their home, they probably know that. But there are cases where location is the thing. So, if you are tracking your things around the globe in any kind of track and trace kind of model, definitely location is the thing that you're trying to get. It may also include other attributes, but location is certainly one of the key elements. So I think we obviously tend towards needing location, and we'll describe why I think it's actually important in most cases, even if it is not the most important thing for your current scenario. So we'll go through some of those situations we've had with customers. So with so many things out there, there's also so much information, and this goes again to why we'll talk about location with respect to this. Sensors are actually really, it's a good time to be a sensor these days. There are so many different and new innovations in sensor technology that are providing new ways to think about problems and solving various customers' problems. But many of these are better if you have location. And the concept on this one is really to think about the location as a fundamental element. So the fact that time, most people would not consider acquiring an event from any device without giving it a timestamp. Often think of the location as a similar fundamental element of this. The key is that you are acquiring other attributes, such as the temperature of the material, the direction of travel. Is this thing open? Is it closed? What's the air quality? Those given location and time, give you much more information about what's going on in the world. And as these devices proliferate, obviously you'll want not only that real-time information, but that data for further analysis. So again, back to the idea of those fundamental elements, and I sort of think of this as, think of myself as Einstein a little bit here in this space-time continuum world. But really, it is an element that, as you think about it, the fabric of the space and time and the operation of those devices over space and time in that arena gives you much more capability to understand what is going on, to solve problems, to understand where problems may have occurred, and obviously sometimes just to find out where your thing is. So the interesting thing here is that you can find needs for location even in stationary items. So I think a good one to think of is the example of trash cans in a municipal. So you have a trash can that is located generally fairly stationary, but it has a periodicity of fullness that is independent of every other trash can. And yet, generally, we deploy trucks around the route to pick up every one of those, regardless of how much trash may have been filled. So the idea being that if you put a sensor on that tells you how full it is, you can dispatch trucks in the proper route at the proper time and save much money. And so we're seeing that happen. That's just one of many where you wouldn't normally think of location as a trash can needing location, but ultimately the business problem is much easier to solve given that information. And then, another example is for market research. For example, if you think about the Coke dispensers where customers can choose to mix and match and create, a million different options of beverages, the marketing value of that from a location technology standpoint is being able to understand behaviors, trends, tastes, proclivity of consumers. So again, those just several of many different use cases you can find out there. And if you are a manufacturer building appliances, for example, and you're relying on registration data for understanding the end consumer and who's using your devices, that's not always very filled. So even if you do fill in a registration at the time of purchase, the likelihood of you going back and updating that if you move is, I would say, trending towards zero. So that little piece of information can be very valuable, both from a consumer understanding, but also from a support and maintenance standpoint. So far we've really been talking about location as a thing, and really it's more of a class than a thing. So often you'll think about location as latitude, longitude, or an address, or a particular store or venue or warehouse. But really location is composed of a number of elements. And the reason I bring this up is I think there's a lot of, I think people rely on GPS and think location equals GPS. And while GPS is a very prevalent technology for providing location, it is not the only thing. And I just kind of wanted, as part of this, to kind of relay some of the things that we think about when we think about location, and the fact that GPS itself contains things like the error estimate. Right. With location, it's not really a measurement so much as an estimate. And the idea behind the error estimate on location is really to provide people more insight into how much value they can place in that location for their specific use case. Is it within 100 meters? Is it within 1,000 meters? Is it within 10 centimeters? Those are the types of elements within a location that help further analysis and decision making. And then beyond those specific elements, the actual representation of that location, as I mentioned before, it could be represented as a building, as a street address. It could be just latitude, longitude, and hopefully error estimate. So there's different ways to think about location, and not all locations are created equal. And you just need to be aware of that in both in the decision process of choosing technology, as well as in the back-end system that's going to be using this, the location.
Right, just to add to that, I was going to say, when you mentioned the back-end system, how are you storing this data? So to say that something is 0.2 miles from the nearest hospital a year ago and storing that and doing that analysis, when things change, when sort of the reference point may change in the future, knowing how you're collecting and storing and representing that data now so that in the future you can make use of it effectively is really important. Yeah,
that's a good point. And we've gone through a number of ways of representing location over the years, so very, very much a point well taken. So anything else on this?
Nope.
Okay. So now moving on, sort of now coming to the crux of the situation for many companies trying to come up with IoT solutions and deploying these. Why isn't location just built in? We've gotten very used to our smartphones just having location built in and available at all times and all ways. But the truth is that that itself was an evolution from no location to GPS only to Wi-Fi only to hybrid positioning. And now really, if you look at all smartphones in general today, really rely on a multiplicity of location technologies. So GPS plus Wi-Fi plus cell and plus other sensors to increase accuracy and extend the viability of location in different directions. So that's great, but we have some major players that have consolidated the market within mobile smartphones. That's not the same case in IoT, in which many things are built custom for a specific use case. What that drives is really this fractured market with respect to location, and sort of forcing makers to make some hard decisions on how to get location into a specific platform with a set of technologies. So that's really the part of the crux of the situation, and we want to help people navigate that specific thing. So there's the chipsets matter, the power platform matters, the accuracy matters. So all of these, and we'll go through these in more detail, but that has driven sort of this variety pack of location that people have to navigate.
Yeah, you'll talk more on the next slide, Kip, but I think we are still surprised all the time how often we see relatively sort of mature and sophisticated technologists maybe go off and start a startup and build a device, even that may have worked with location one way or another in the past, but get to a point where they've already gone through prototyping and deploying and are maybe in a beta and come and reach out to Skyhook inbound to say, I just now realized that GPS alone wasn't going to work for my specific case. Again, for certain use cases, all outdoors, and depending on the quality of that sensor and otherwise, it may make sense to just have GPS. Airplanes is a great example. But in this case, we have people reach out to us, and it's surprising to sort of see these people come and say, I didn't realize that it was this hybrid technology sort of being the sort of basis and smartphone baseline, and now I need to apply that to my use case as well.
Yeah. And I think that's an important thing to realize also, that the sensors and antennas that are built in and designed and engineered for the iPhone and Android devices, there's a lot more money going into those.
Right.
I think we get kind of used to the performance of those and sort of wonder why these small devices don't meet that same high expectation. But on to sort of the idea of what are the location dimensions, and this is kind of how we think about going through it when a customer says, here's my use case, here's the scenario I'm trying to solve, what should I be really looking at, and how should I think about location within that sort of design goal. And so this, I won't go through all of these. I'll leave some of these for you to read through. But really, some of the key ones, obviously accuracy, right? Different location technologies provide different levels of accuracy, and often it varies through some of these other dimensions. For example, it may vary within an environment. So how does it perform indoor versus outdoor? How does it perform in urban versus suburban? Those are things that are sort of cross purposes with your accuracy. Beyond that really is the idea of power. Obviously, anybody working on a IoT solution is very sensitive to power consumption. And while we've always been pushed by manufacturers and smartphones and apps and everybody to be power conscious with respect to location, this really takes it to a whole new level of scrutiny and capabilities, right? I can only use very, very, very little battery. And so, the technology that you use is highly dependent on the capabilities of the rest of the device, right? So if you really have a small battery that is going to live for a couple years, powering, a full-time GPS chip or periodic GPS chip may be too much, right? It may be the right answer. But you can think about other lower power solutions that may get you to the accuracy that you didn't need without going through that. The next one really, which is closely coupled in my world with is sensors and carriage, right? As you think about the radios that are put on a specific device to allow communications and network connectivity, many of those can also double as a location technology. And what we try to find is those customers that have that capability already built in, or the easy ability to add something like this, for example, a Wi-Fi chipset to an existing solution to solve the problem without really changing the entire footprint of their device. So, the key really on the carriage, obviously, are Wi-Fi, LPWAN, cell, and then to a lesser, extent, but wired is still for some technologies usefulness. So the other one is I want to walk through is really on the sensor. So as you can see, there's a number of overlaps within these two columns. In particular, for Skyhook, Wi-Fi and cellular, and increasingly LPWAN are areas that we see a good overlap with the carriage and the location capabilities. Obviously, GPS is well known and very capable, and is a piece that we use in our system quite frequently if it's available. So I think that hopefully gives you a sense for how we think about this, and I'll pass this over to Nick to really walk through what this looks like in real-world deployments and how we've helped customers with this methodology.
Thanks, Kip. So I just want to use a few use cases to sort of show how these dimensions and the selection and how it took place for customers and partners of ours. One of them is there's a big business, especially in North America. Unfortunately, as an American, a lot of criminals and a lot of people going through that system. So parolee tracker or offender tracking devices, the common ankle bracelet. It's been a big business for quite some time, especially how it's sort of leased and licensed through the government and regulated. So in terms of accuracy for one of our partners, you're looking at 20 to 100 meters of accuracy. At all times, you want to be able to send a search party or someone to this location to be able to corner a potential suspect. In terms of mobility, it has to be mobile. It can't this person is a human, even if they're on house arrest or limited to the destinations they can or allowed to go, they're moving. In terms of power, so it's a rechargeable battery. I believe it lasts a week plus, and there's really cool technology and sort of security around, having to replace the battery and recharge it, and you have to do that in a number of seconds before sort of your parole officer is called. So in terms of making sure that maintains charge, obviously power conscious is part of sort of making that long lasting and avoiding those steps. In terms of carriage, so in one of our major partners, they actually had Wi-Fi and cell in terms of carriage, so they had a base station, and a lot of historically, even with the Philips Lifeline iPhone I Can't Get Up devices, historically had a base station that the device connected to when at home to know that someone was nearby, just proximity, and then when you'd go outside, it would use GPS. And that's sort of the use case that missed was dense urban environments or indoors anywhere else, maybe where that GPS wasn't valid. So these guys had Wi-Fi, simply partners of ours, to do backhaul when the person was home and use that network with the base station. A different partner of ours in the same space didn't have Wi-Fi, but has since got Wi-Fi purely for location. They were using Bluetooth to connect to that base station. Environments, obviously, this has to work everywhere a person can possibly go. Morphology, all, dense urban environments, suburban environments, or rural, that hybridization of Wi-Fi, cell, and GPS to get to that level of accuracy. In terms of security to think about, for these guys in law enforcement, it's not at sort of the national security level, but they're taking steps to secure that data in certain ways between user, police stations, other parole officers, and access to that data and how it's anonymized and ability for the public to track, et cetera. And then again, the sensors, GPS, Wi-Fi, and cell. So in this specific case, it sort of mimics the smartphone sensor technology in what was accessible for location specifically, and of course, not all and many use cases don't, but in this case it did.
Yeah, and I was just going to add that, like any good company, we really eat our dog food here. So everybody here has a fender tracker on their ankle, and
right.
Just kidding.
Exactly. Going to the next case here. So this was actually a really interesting one. We had an appliance manufacturer reach out to us after a show, and they were both retrofitting devices to sort of keep up with smart innovation, but also sending their new appliances out, obviously, with Wi-Fi modules. And the reason they came to us is they had a case where they had warranty and replacement issues with a part within these, specifically was washing machines. They wanted to see if they could figure out any insights from location. So as Kip talked about earlier, as an attribute to the other data being sent when a consumer plugs in this washing machine at home, back for warranty repair and sort of diagnostic in general, they didn't have location as a function. What we ended up doing is replaying Wi-Fi scans for these to identify where the issues and problems were with this specific part, and adding location as an attribute. So what ended up happening is they were spending a ton of research dollars trying to figure out what was going on, and they couldn't reproduce this issue in-house. And it ended up being actually altitude that was impacting this specific part. So when they were able to plot everything based on the location of these washing machines, they were able to identify trends and see that over certain altitude was where the part malfunctioned. They were able to reproduce, replace and fix the part, and sort of saving themselves money in the future. So in this case, it was a stationary device. They didn't care about super level of accuracy. It's over 100 meters. So they already had Wi-Fi. It was sort of easy to go then in the future and retrofit and deploy a firmware update and have sort of real-time location coming with their other diagnostic info going forward, which we did. The environment was indoors. So in this specific case, GPS or other technology wasn't valuable. And again, they already had Wi-Fi on board. Personal level of security, and again, work in all morphology, but again, just basically where people live and would have an appliance. But a really great and useful use case to talk about and see how it applied to them from an analytics perspective.
Yeah, that's a good one. I like that.
So I'm not going to go through this entire chart, but we talked about the location dimensions to sort of think about. But in terms of technology selection, thinking about those as well. So what sensors and what type of technology and the trade-offs between these things. And I should say that it can be a little confusing here, but green means basically a sort of positive assessment and red is negative, with yellow being in between. So again, I'm not going to go through all these technologies, but things to think about. Does this require new infrastructure? So in my environment, for our case, again, we're talking about our technologies. Maybe I already have Wi-Fi, or I want to augment that in some way for, centimeter level accuracy, something to think about. Does it require a survey or a resurvey of the environment if I use some sort of fingerprinting and other technology to get indoor level accuracy? What type of power does that sensor or approach consume? Again, the environment, indoors, outdoors, and then if outdoors, urban, suburban, rural. And then sort of the footprint for the technology. So you think of LP1, which I'll talk about here in a second, low powered wide area networks. In the past couple years, if you wanted a global deployment, it really wasn't practical based on regional operators getting up. But now, depending on where you're targeting, it very much can be. If you're looking at Europe and North America or sort of the APAC region and targeting those, there are these networks and they're available for all those different places. So just something to think about. What is the footprint of these technologies and how they work together? Are they on the network side? Or are they on the client side? And then, of course, sort of the main point for location-specific cases, what level of accuracy are you looking for? You're looking for the sort of centimeter-level indoor accuracy where you can fully augment your environment. Are you looking for GPS-level accuracy outdoors with air, as Kip talked about? Again, using Bluetooth and BLE for many cases and controlled can be good. You talk about conference centers which have now gotten APs or Wi-Fi access points with Bluetooth in them. That sort of hybridization, having access to the network, Bluetooth can be very effective as well. So just think about the level of accuracy you're trying to attain and all these other trade-offs for your use case. So as I mentioned, I'd sort of be remiss if we didn't talk about LP1 and especially how these inbound inquiries have been coming to us in the space, particularly around location. But LP1 stands for low power wide area networks. So these are networks specifically designed for sort of the IoT or MDM use case where they're low bandwidth. They have some sort of limit in the amount of data a device can transmit in a day, typically. And they're built because of these constraints for devices that have very long battery life. So you're talking about batteries that last years and years for sort of the life cycle of the device. So some examples of that are Ingenu. The big ones you might have heard of that were battling over the last few years for sort of supremacy are LoRa and Sigfox. Again, the ones from the carriers are LTE-M1 or the NB-IoT variant. And then there's smaller ones like Weightless or others that you'll hear about around events. But in general, so when you're thinking about potentially using these networks for your IoT solution, they can be great and even amazing and cost-effective and fit your exact use case. From a location perspective, these guys take a network approach. So natively getting location for free requires that you have, which you may have to anyway, a relationship with that network provider to get that data. And these guys are using sort of the network-centric time of arrival. So they're calculating the differential time of arrival between the uplink or messages coming from the device to the different gateways around them and doing that calculation based on the difference of time to tell you where a device is likely at. So in terms of accuracy, you're talking about, they state city blocks publicly, or it can be up to tens of kilometers, so it can vary greatly. A lot of that is determined by the network configuration. So, do I have gateways around me that are set up in a perfect triangle, a couple kilometers from my house where I have a device? It could be pretty good in that city block level. If I'm out in the middle of the country and there's, one gateway in the middle of Nebraska, which I always pick on because that's where Kip's from.
I don't think there's one there.
It could be the tens of kilometers. So just things to consider. Again, we sort of started as the Wi-Fi company. We're having a lot of inbound requests now that people are saying, this worked great for me, but I need a location-specific solution. So I'm considering adding Wi-Fi, not for any network backhaul, but purely to perform scans when necessary to transmit that data to use Skyhook because I want enhanced level of accuracy for this use case.
Yeah, and I was going to say that the fact working with customers like this, I mentioned earlier, and many of our customers drive us even harder. This is one area which is definitely driving us to find new ways to manage data And I think Nick will go into that a little bit more later, but really it's these types of customer requirements coming in that help us sort of drive forward.
Absolutely. So in terms of Skyhook's location or IoT solution, so I'll breeze through this. We've touched on it quite a bit so far, but typically in all of our sort of native standard SDKs, Android, any OS, we have a hybridization of Wi-Fi cell or GNSS. Any combination of those two or those two individually. A lot more recently we've had cell-only type location solutions as well, whether that's in sort of the LP1 or traditional cell networks. We've been very flexible in terms of our integration options, so starting out with those fully featured SDK client-side libraries to a server JSON XML API to sort of providing the tools which we call the light client, which are portions of our SDK to build and backport and customize for OSs, to what evolved into what we call the embedded client. So the embedded client was sort of something over the past few years we developed to be a bit elegant in its simplicity. So it's the sort of lightweight C library or source that people can embed at the firmware level or whatever level you'd like to integrate, and just provide the minimum amount of code footprint possible to sort of embed and ship with their devices. Again, we're always conscious around power, how much client code is used, what's the scanning code, we'll talk about that a little bit more, what IPs are selected, the storage, the memory, making sure these constraints fit to your specific use case device and you're making those trade-offs effectively. So in terms of what we just talked about, we get the sort of inquiry all the time, hey Skyhook, you're the Wi-Fi company, and we want access to your database, which is great. It's probably our largest data asset for sure. But what I think people don't often understand is there's some complexity and quite a bit of heavy lifting behind the scenes, and also features that fit different use cases that aren't just a network request based on Wi-Fi signal scans or any other signal scan and providing back a location. And some of those things we've innovated over the years are, for example, data optimization. So we were just talking about the LP1 use case or other use cases where you're limited to the amount of bandwidth a device can use. So that is data optimization. On the client side, we're optimizing what access points are you selecting. Are they remote access points? Are they APs that move, so you don't want to select access points that might be identified as moving trains or Wi-Fi hotspots or mobile phones? You also might get an understanding about their stability or relationship if it's one access point broadcasting multiple MAC addresses, so we call those virtual APs, and we collapse those. So there's a lot of things to consider to say, if for my device, based on the limitations, I can only send 5 access points, what are the best 5 to select out of these 20 my device sees? How do I optimize that? How do I use compression and a binary protocol to get that to where I need to get to resolve location?
Yeah, I was just going to say that, like I said, with the LP1, one of the constraints is on that bandwidth, and it's what's interesting is the sort of reversion to the 80s kind of conversation. Right. Because now we're talking about bits and bytes, not megabytes and kilobytes. So it really is it's an interesting move back to try to think about this in a constrained environment where, if you're thinking about smartphones, the constraints are a little less stringent.
Right. Especially for location relative to streaming YouTube videos or something.
Yeah, like exactly.
But you're right. You're talking about Sigfox just as an example where, 12 bytes of data can be transmitted in each uplink from a device in sort of a 26-byte frame, which includes the overhead, and talking about 140 messages per day, which is what do you want to send, when do you want to send it, how much of that do you want to send for what you're trying to do or perform function. You're right about that. Some of the other things sort of as this innovation, so I won't touch on all these again, but 2 cool ones. Tiling, so this idea that we enabled and patented for smartphone technology, which is applied to many IoT use cases for offline location, is caching portions of our database or other information locally on the device, so the device doesn't need to make a network request to, say, perform a Wi-Fi scan and see where itself it is. Other offline features are tokening, so you think of a wearable or fitness tracker or something else, even an asset tracking device that may go dark and not have network connectivity, but can still perform scans of some sort and package up that information, and when it gets network connectivity, resolve its path over time, which is extremely valuable. So we're spending time taking a lot of those standard SDK features and working with partners to port them to their specific device and sort of create that standard embedded feature set for those same things. And then one other of those is quarantine. We talked on the client side for data optimization and selection, but quarantine is important as well, which is in our back end when we process all this crowdsourced data and reposition beacons, we call them, whether that's cells or Wi-Fi access points, which ones are bad for location, which ones move, which ones are suspect, which ones might be locally administered and be duplicates. So there's a lot of intelligence that goes into cleansing and sanitizing and pulling out, in the terms of quarantine, the sick APs out of that pool and making sure those aren't used for location. So just a few other use cases. We talked about some of these already. So cold storage logistics, shipping things that need to be refrigerated, a big use case for us. Even more recently, we have two partners that do this with hybrid Wi-Fi and cell positioning only. So they're looking when they can get more accurate inside urban environments. That's great, sort of points of reference. Otherwise, when you're traveling cross country, sort of the cell, multi-base cell positioning is fine. But again, the other information you're tracking with that is location, temperature, humidity, time. So we even have a newer partner who's doing this just with cell only. So they're not using Wi-Fi, they're just using cell to get general location information for where that asset is in association with the other information they're getting. So an appliance manufacturer, we mentioned the case before with sort of washing machine use case. We have another appliance partner who basically uses this information from a manufacturer, not from a consumer standpoint, to track an appliance from factory when it's tested and plugged into, then figure out at the end of the day where this device ends up. So of course all the privacy and sort of opt-in considerations are taken into account there, but they also, when they get sort of high-level demographic information about where this ends up. So from also warranty and service calls and knowing where this is, but from also a future planning and targeting and marketing perspective, with Kip you brought up prior, extremely valuable. Some other cases is Philip Child smartwatch, BI is that company with the sort of world's leader in offender tracking. Armada is a board that's used for just pure asset tracking in general, so in the supply chain and logistics. In terms of other IoT use cases, I won't go through all these in detail. We've got a lot of inbound inquiries lately for indoor location for giant warehouses, or that industrial IoT use case. How do I find a big jet engine repair tool that I use so often because it reduces my cost by X if I can improve efficiency there. Geofencing when things leave a campus type environment. Of course, supply chain, general device intelligence. But the one thing I'll mention is big data analysis. So the idea of, we've talked a lot about how location and sort of real time or close to real time is valuable in all these cases, but arguably it's more valuable for the business to analyze past location data. So as Kip talked about before, marrying this up with other information to improve efficiencies. You think of sort of city planning, it's become huge now in the Smart Cities initiative. So all sorts of situations. We recently did a project at the US Open for sort of analyzing crowd movement in general. So a lot of this analysis for future planning and optimization is extremely important using location data.
So we wanted to leave you with this slide on just what questions are reasonable to ask a location vendor or supplier as you go through this process. At least do the mental exercise of walking through many of these to understand how the different solutions fit into your requirements and your expectations. So I won't go through all of these, but obviously you want to find that that match which fits your overall battery communication and location expectations to the best of your ability. Obviously, there's going to be trade-offs along the line, and I just sort of put this in front of you guys so you can think about all of the questions that really are relevant to location. and understanding location and the technology and vendor that you choose. So I think with that, we are at the question point in the discussion.
I think so.
True?
We are. Kip and Nick, thanks for that excellent presentation. We'll get started with today's Q&A session, and I want to thank the audience for their participation. We have great questions that have come in during the presentation, and we'll do our best to get through all of them in the time remaining. During this Q&A session, I'll leave up this screen with contact information for Kip and Nick if you'd like to contact them following today's webinar. So let's get started. A couple questions first on Wi-Fi. How accurate is Wi-Fi location technology?
I'll jump out. Yeah, that's a great question. We obviously get that one all the time. So we've historically been focused on sort of global support and global penetration in terms of coverage for Wi-Fi. So I can say, from that perspective, you're looking at, on average, with the statistics, 20 to 30 meters accuracy over the world. In terms of signal propagation, if you do a survey of an environment, you're talking to 3 to 5 meters. So if you know exactly where APs are positioned, you survey them or get their exact location, not crowdsourced, you're talking about 3 to 5 meters.
The second question on Wi-Fi, do I need to connect to a Wi-Fi access point to use Wi-Fi location?
The answer would be no. What's great about the Wi-Fi protocol is the access points are constantly sending out their beacon and their MAC address and information. So the need to connect is not required. And in fact, there's some new specs and new standards in the 802.11 space, in the Wi-Fi space. 802.11 2016 includes timing measurements, so the fine timing measurement capability. So that actually goes to the previous question as well, which is there's continuous evolution in Wi-Fi capabilities, and by providing these fine timing measurements, and again, it's pre-session, so no need to connect, but you can establish a finer grained location using that technology into the meter range. And there's another spec coming probably next year that actually takes it even further. But there are chipsets available that support the fine timing measurement, actually have been certified by the Wi-Fi Alliance. And so that's an exciting area, I think, as the industry moves forward.
And just to add in sort of layman's terms to Kip's response, I think just understanding a Wi-Fi scan. So when you go to a device, your phone, your laptop, and you drop down to select what Wi-Fi you want to connect to, that's part of the protocol, right? Your device pings out and says, "Hey, I'm here," and everything shouts back at it, and that scan is what allows us to do Wi-Fi-based localization.
Great. Let's shift gears here a little bit. You talked a lot about on use cases with an appliance manufacturer. In appliance management, what about privacy? I would suppose that this question is about privacy in general with these devices.
Yeah, that's a great question. Specifically in that use case, it was very sensitive. I know in the past few years, you've sort of seen things in the news about different use cases and different permissions and hidden terms and conditions. I would say across the board, we have sort of mobile application SDKs as well, where we build our technology out to allow both for sort of all hands permissions, and then from there build the safeguards to make sure that we have user permissions as well. So in the appliance perspective, we're making sure, and a lot of times when we walk through a use case, especially if it's atypical at first, both through legal, but also through how our technology works, making sure that there's the valid acceptance, working with that partner to make sure for the appliance case, when it gets to the user, it's in the T's and C's and known how and how the data would be used and anonymized, et cetera, so that it's not used maliciously, and it's also typically used with the user's consent.
Great, thank you. Question about tracking in a warehouse. Is there a way to track within a warehouse, or what will be a probable solution for it?
Yeah, I'll let Kip jump in as well, but I mean, it's a bit of a loaded question, but it's not to say we don't get it all the time. I mean, I think sort of that goes through those location dimensions a little bit. I mean, I know there's technologies that aren't ours that people use all the time in terms of RFID in warehouses for tracking assets. We have several partners and customers who use, it just came easy for them. So one example is we had a partner who has a multi-mile warehouse. They already had sort of scanning devices for just checking things in and out. Those scanning devices were connected to Wi-Fi. So in this case, they were just trying to track boxes. And actually, the use case came in, they were trying to just track those devices so they didn't lose them and made sure they were powered up. And in addition to that, we said, well, when you scan these, why don't you tag them with the indoor location to 5 meters of accuracy that was coming from the device into your system. So there's tons of different approaches to take. Again, you can take sort of the network approach. If you make and control that, you can augment your environment with ultra-wideband, DLE, get into sort of the indoor location space, but it's wide open.
Yeah, I think I would say it depends. Again, to echo Nick, it really does though. The level of accuracy. What is the specific case? Is it on an assembly line tracking kind of thing where ultra fine location is required? Is it I want entry exit? Is it I want zone? Aisle level? All those stuff. So and I think that's why this is a real challenge for customers to come up with, because you always hate to have, well, it depends, and then, we're going to have to run through a pilot, right? And that's, I've heard this from a number of customers out there that, by the time they get done with the pilots, they've already spent their budget. So I think it's incumbent on the industry to really get better at this and come with solutions and not just technologies. And that's really what we're trying to focus on in those areas where we excel, to really come up with solutions that provide our customers the capabilities without having to go through this painful pilot process and try to understand the capabilities.
Thank you. Getting a lot of good questions. Here's an important one. How do you go about with software updates?
So software updates from our standpoint or from the customer standpoint is two different things. But so we have a continuous evolution of our software on the client code, whether it's the embedded client or our full-featured SDK, that just allows customers to roll that in. From a server standpoint, we maintain backwards compatibility. I would say probably back to 2007-ish right now. So we really try to limit the disruption to our customers and not force upgrades. Of course, there are a lot of over-the-air upgrade for many of our customers that can do that. We do have customers that have shipped and have no way to upgrade. So again, that requires a commitment to backwards compatibility to support those.
Yeah, and I would say it also depends on sort of the integration model as well, right? We have customers or sort of channel customers, I'll say, that through partnerships, whether we're integrated in an IoT platform so they don't have to worry about that, and they're worried about sort of upgrading one client, and the platform provides the mechanisms to push, either manage their assets or push firmware updates, or they manage, and we get that a lot, probably more than some might think, people that manage things themselves for security or other internal purposes, and they're really managing that OTA update. And there have been times where we have to sort of coordinate, but just purely for the sake of making sure that they get rolled out and providing data to all these customers' devices.
Great. Coming back to another Wi-Fi question. How much will it cost to add Wi-Fi to my IoT device?
That is a great question. So you can, it's sort of in hardware, I guess unless you're talking to someone in the module space, it's beginning to get commoditized. So as it gets more competitive, especially the technology like Wi-Fi that's now been around for a while, you can go onto sort of Alibaba or those sites and get, just 10 relatively high quality Wi-Fi modules for $1 or $2, which is sort of crazy based in the olden days. I think the other thing, to Kip's point, is it depends on your use case as well. If you're using it for backhaul and connectivity, you can take additional considerations, or if you're just using it for location to add it to your device, then you can get these sort of scan-only modules from the likes of TI and others that don't necessarily have the capability to even connect and transmit data. It's just for the scan capability. So depends on your use case, but it can be as low as a couple dollars, and that obviously that's going to even go down further based on how many you're ordering.
Well, I think we have time for just a couple more questions. This one's an interesting one. I want to say the answer in my head. I'm going to guess it, but I'm not going to say it. I'm going to let you guys try to answer it. And it's about the military. Military gear such as the cruise missile had a fairly accurate honing capability regarding pinpointing the location before IoT became an acronym. How did they do it? Comparing this with the location services that Skyhook is offering today.
Well, that's a fine question. I'm going to have to do some research on that specific technology they use. I'm not sure if that's published out there in the public, but likely. I would say that to date we haven't, I don't think, been used to deploy a missile to guide a missile, but
I can confirm that.
Yeah. You've done appliances.
Yeah. So yeah, I think I think the military and those types of situations, they often use multiple technologies. Obviously, there's always a concern with those with spoofing or jamming or other type of many of those are using redundant technologies and frequencies and ultra wideband and things like that. I'm not familiar exactly with what's being used, but we often do see the use of multiple technologies to try to detect if there's nefarious behavior or just error in the system. So using cell plus Wi-Fi or using GPS plus cell, and using those different technologies, different frequencies, and different radios to try to detect if one of those is being compromised.
Yeah, and I think, we talked a lot about augmenting GNSS location. I think, our engineers and people in our innovation research team know much more than I, but there's access to information that sort of public has in the, GPS, specifically the North American GNSS constellation and otherwise, and then that's extended obviously within the military to what other information and attributes of that data they're provided. But it's not to say that if you go outside, even with sort of consumer-based, GPS radio today, you can't get extremely, extremely accurate outdoors. It's just considering when that makes sense and not. And for a rocket, obviously, that's typically not in dense urban environments driving around. That.
Yeah, I'll dig into that. That'll be interesting. I could post a follow-up on that.
Well, thank you for that, and thank you for great answers to some very good questions. For those of you that asked questions that weren't answered, we will be sending all unanswered questions to our panelists and the Skyhook team so that they can follow up with you after today's webinar. I have a few quick announcements. Please mark your calendars for September 12th and our next IoT Central webinar sponsored by Vertica. Also, this taping will be available for on-demand viewing later today and can be found on the homepage of IoT Central at iotcentral.io. This brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Skyhook for their sponsorship, as well as to our speakers Kip Jones and Nick Nellinger for their insight into today's topic. My name is David Oro, and I'm very pleased to have been your host. I look forward to seeing you all again on September 12th. Have a great day.